Alright, what I would like to do today is I would like to do a continuation on from the activity that we started on Monday, which was the partner reading. And what I'm going to do today is we are going to talk about that again in the group like we had done last week. This time I'm also going to supplement some of my notes along with that. So what I need for you to have out now is your book open to page 334. Okay, 334. And also the paper that you had started to take that dialogue down with your partner, and also your notebook. Okay? So we're going to be going through, and we are now going to discuss as a group what you discussed in your partner teams. So again, I'm going to ask that you guys lead that discussion, and I will fill in blanks wherever we find those blanks to be at. So this section, again, if you look on page 334, is talking about what mainly? Kira?
The fossil record.
Right. And what is so important about that fossil record? What can it do for geologists? Rachel?
It can help determine the relative age of rocks.
That's correct. It can help us to determine the relative age of rocks. How can it do that? How is it able to help us determine relative age of rocks?
Fossils.
Go ahead. Your first one that you were saying.
Index fossils.
And what does the index fossil help do? What is it? What kind of fossil? You're right, it's a fossil, we know that. But what kind of fossil? Talk to me about it.
It's like, if it's an index fossil, it's like throughout a large, like, area.
Okay, what else?
It's like the time span is relatively short.
Correct. Okay, so with it being widespread geologically, and with it living in such a short time frame, why to determine relative ages of rock? Occurring in a wide span, geologic area, and occurring for a short time. How does that help geologists to determine the relative age? Rachel?
The rock layer in which the index fossil was found can be dated very accurately.
Right. Because it existed for such a short time period, a geologist is then able to determine that age of that specific rock because of that short time span of the index fossil. Questions about that? Clark?
When you said live during a short time, like how many years do you mean? Like years?
Now think about, in terms of geological time, a short time could be 1,000 years. These are typically looking at, because if you think of geologic time span, which is what we're going to talk about next week, you'll see that it can be 1,000 years, or it could be 10. Okay, so we talked about how we can date layers of rock by utilizing fossils, but let's talk about how we get fossils. Okay, your first bullet to discuss with your partner was to do what, Ian?
Describe 4 ways in which entire organisms can be preserved as.
Okay, let's discuss one of those ways now. Jackie?
Modification.
Talk to me about what that is.
Modification is like, it's really simple. It's just like if something was something that's dry and then dry to preserve and stuff.
Okay, where do we typically find mummification? Kat?
We're on the ceiling.
Where do we typically find mummification? Michael?
We typically find mummification in desert caves or buried beneath the desert sand.
Good. Why would we find them there? Clark?
Because it's dry and hot and bacteria can't really survive there.
Awesome. Good job. Correct. All right, that's one of the ways. What's another?
Do you mind? Because I didn't get all the bottom notes.
Yes. I'll get them for you. Okay. What's another way that we can preserve? Marcus,
Amber.
talk to me about that.
Amber is hardened tree sap that insects become trapped in the sticky sap and are preserved when the sap is hardened.
Awesome. Give me an example of this. Clark?
Like